Bismillahirrahmanirrahim. Assalamualaikum students. As you know that in our last lecture we discussed about the transverse stationary waves in straight string. Here we consider a string of length L and mass M which is fixed in between 2 points such that it's having tension T. So in first case we plug that string at the center point and we generate the two pulses in a string which move towards the fixed end. And after reflection from the fixed end, these two pulses meet or superpose at the center point, and after superposition, this whole string vibrates in a single loop. We derive the expression of the wavelength and frequency for this case. That the first wavelength when we plug the string at the center point is equal to 2L. And the frequency F1 is equal to 2V divided by 2L. Here V is the speed and we know that speed of the transverse wave is T divided by M, where T is tension and M is the mass per unit length, and we call that frequency fundamental frequency. After that we also discuss the second case when we plug that string at 1/4 part and we generate the pulse after reflection. These two pulses superpose and this whole string vibrate in two loops. And we also find the expression of the frequency as well as the wavelength for second case when string vibrate in two complete loops, such that the second wavelength lambda 2 is equal to 2L divided by 2 and the second frequency is double of the fundamental frequency or first frequency. Now we discuss the third case when we plug that string of length L, mass M and having tension T at 1/6 part. Then after reflection of the waves there is superposition of the waves and this whole string vibrates in 3 complete loops. We know that the points where particles are in state of rest, we call these points nodes. So this one is node. Here we also get node, node and node. And the distance between two nodes is lambda by 2, means the distance between two consecutive nodes is half of wavelength. And again this distance is lambda by 2, lambda is wavelength and half of wavelength is the distance between two consecutive nodes. Here we get lambda divided by 2. As we discussed the third case, so we can write lambda 3 by 2, lambda 3 by 2, lambda 3 by 2. Now if we write the expression for the length of this string, this whole length from this point to that one, this length is equal to sum of these three values. L is equal to lambda 3 by 2 plus lambda 3 by 2 plus lambda 3 by 2. Now we take the LCM. We can write L is equal to lambda 3 plus lambda 3 plus lambda 3 divided by 2. Or we can write L is equal to 1 plus 1 plus 1. We have 3 lambda 3 divided by 2. And if we want to find the expression for the wavelength, we can write lambda 3 is equal to 2L divided by 3. Here we multiply 2 on other side and we divide 3 over L, we get this expression. This is the expression for wavelength when we plug the string fixed between 2 points at 1/6 part, such that this whole string vibrates in 3 complete loops and the wavelength of the stationary waves is equal to 2L divided by 3. As we get the expression of the wavelength, lambda 3 is equal to 2L divided by 3. Now, if we want to find the frequency of the stationary wave, we can use the expression frequency of the stationary wave generated when we plug the string at 1/6 watt, we can use the expression V is equal to F lambda. For third case, we can write F3 lambda 3. Here we want to find the value of frequency. So we can write F3 is equal to V divided by lambda 3. Here lambda 3 is equal to 2L divided by 3. So we can write F3 is equal to V divided by 2L divided by 3, or F3 is equal to 3V divided by 2L. Here 3 is on third place, so we can multiply it over. We can take it as a nominator term. It's multiplied by V, we get 3V divided by 2L. This is the expression for the frequency when we plug the string at 1/6 watt. We know that this V divided by 2L is equal to fundamental frequency denoted by F1. So we can write F3 is equal to 3 times F1. We have a different value of frequency as well as wavelength. When we plug the string at various parts, first we plugged it at center, we get wavelength lambda 1 is equal to 2L. When we plugged it at 1/4 part, we get lambda 2L, lambda 2 is equal to 2L divided by 2. For third case, we get 2L divided by 3. Similarly, we get three different expressions of the frequency, that the first frequency having certain value and the second frequency is equal to 2 times F1 and third frequency is equal to 3 times F1. Now we want to find the expression for frequency as well as wavelength when we plug the string at any arbitrary point. We generalize the value of the frequency as well as wavelength when we plug the string at any point.